my first story this evening. As I mentioned in the listing of stories, Epstein-Barr virus has been identified and in previous years was identified as a potential viral cause or a trigger for autoimmune diseases like multiple sclerosis or lupus. And it's been this kind of loosey-goosey connection for a while. It's more and more evidence is being amassed, and so the hypotheses are getting tighter. And this week, a study is out that is, I think, very exciting. Researchers published in Science Translational Medicine their study looking at how Epstein-Barr virus may be that actual cause or a driver of autoimmune disease. And in this case, they tie it to systemic lupus erythematosus. So in their study, they did use machine learning to do some of their analyses. But what they were really interested in is how Epstein-Barr virus infection actually impacts your immune cells. And what they determined is that by using a new strategy to identify these, what we'll call EBV, Epstein-Barr virus infected cells, they used RNA sequencing to be able to look at the immune cells, B cells, T cells, et cetera. Using RNA sequencing, we're able to see that infected B cells, and B cells are type immune cells of the body that are like the first kind of layer of in the first layers of defense. They are memory cells. And so you can have B cells that then talk to helper T cells, and then helper T cells go on to program and make more B cells so that your body's ready the next time it needs to fight. Anyway, when Epstein-Barr virus infects B cells, these immune memory cells, it makes the B cells basically do a antigen presentation on the outside of themselves. And so the helper T cells go, oh, what's the antigen that I am being presented with? And the helper T cells go and like grab onto that antigen that the B cells going, look, I have an antigen. This is a thing we should be fighting. Well, it turns out that antigen is from the nucleus of the B cell. So it is an antigen that is part of your immune cells. So the Epstein-Barr virus gets into the immune cells, and basically when it does its integration into the DNA and gets itself reproduced using the cellular machinery to make more EBV particles, in the process, it somehow, with RNA splicing, gets the B cells to put themselves on the outside and not the viral antigen. So then the T cells are like, ooh, look at this bad thing, this bad boy. We got to get memory cells and fight it. And so basically, it starts a self-perpetuating cascade of the immune system highlighting your body, your own cells within the immune system as targets for attack. And so this is this is I think understanding this process is one of the, I think, very important aspects of being able to treat autoimmune diseases as we move forward. Because if we understand how Epstein-Barr virus is, it's probably one of many different causes of these diseases, but at the same time, if we can figure out how to stop it, if we can create a vaccine for it, if we can create a treatment that can just get in there and short circuit this particular immune system signaling cascade, then it can be, the potential is really great. And it also potentially this whole thing explains like why interleukins are so effective in their use for treating multiple sclerosis or lupus and other autoimmune diseases. Anyway, this is pretty big news. Understanding how this all works, uh, it's essential to helping us live longer, healthier lives. And for those of us with family members and potential genetic predispositions to some of these autoimmune disorders, uh, it's kind of it's you start to breathe a little sigh of relief that there might be more treatments on the way, maybe even cures. We'll see. Epstein-Barr virus is, and no, it's not the Epstein-Barr papers, the virus papers. No, Congress has nothing to do with these, Kevin Reardon. This has nothing to do with the newly sworn in congressperson in the Epstein papers that, we'll see if we actually ever see anything. Um, this is actual science. Actual science. Oh my gosh. So, yeah, Epstein-Barr virus. You might know it as more commonly as it's a virus that causes mononucleosis, right? It's a virus, the kissing disease. Epstein-Barr virus is not something that most people are really affected by very strongly when they're infected by it. So Epstein-Barr virus, you can be infected by it and then just be like, "Oh, I felt bad for a little while," and never even know it. But for those people who have genetic predispositions, or maybe there is also some tie-in with current levels of stress in the body or environmental conditions, or whatever is going on, um, it has this potential to impact, to cause lifelong diseases that I think, interestingly, come into play later in life when there are hormonal changes, immune system changes, and additionally, that tend to kind of ebb and flow so that you can have a period of high activity of the autoimmune disease, and then it goes into a remission again. And I think all of these aspects of these diseases, which has been so confusing for so many